So let us come back to part 4, which is a continuation of part 3 only. We continue doing sums. So here we get this kind of thing, that x minus 2 divided by x plus 5. Okay. So what we do over here, we bring this 2 to this side and do a kind of subtraction. So x minus 2 into this. So when you do, okay, so you get x minus 2x, that is minus x, and minus 2 and minus 10, so minus 12. So we get this thing. So I can take a common minus and reverse the sign. So next step I will write, hope you understand this, x plus 5, the minus sign, this will reverse this sign. Okay. Now you have seen in relation function also this kind of thing happens. When this kind of thing is there, it means that it's negative, means you have to make it sure that one of this is negative, either numerator or denominator. Okay. So what we do, we multiply. I told you earlier also, the denominator with both this numerator and denominator. Then it will be like this. Then what will happen? The denominator, look at it, it is positive. Why positive? Because it is a square. So this is positive. That means the numerator should be negative. Why? Because negative by positive is negative. That means we can make it sure that since the denominator is positive, the numerator must be negative. Okay. Now, you know, like here we always solve the number line. This means x is equal to minus 12. This means x is equal to minus 5. So there are 3 regions in the number line. You know, there are 3 regions. Now, if you put a 0 over here, then what happens? It becomes 60. So this side and this side, if you put some number more than minus 5, if you put a if you put a 0 over here, which is over here, so it's not satisfied. So if you put something between this, say minus 6, if you put, so this becomes negative, this becomes positive, product becomes negative. So it's within this, that means x belongs to minus 12 to minus 5. So that means what we are doing, we are taking 3 random numbers from the 3 intervals. Okay. So we get this answer. We get a number from here, I took a 0. So that's why I put 0 over here and got the product as 60. 60 is not lesser than 0. So that's why I crossed it. So this is all with this question. Let us see some next thing. See, I tell you something, there is a sum over here. In this kind of situation, you should not cross multiply. 4x is greater than 2x plus 1, you should not do that. Because why, you know, if you do that, the denominator 2x plus 1 criteria is lost. Okay. That means that particular interval will be lost. So I will show you what problem will be there. So in this kind of thing, always try to bring the fraction so that you can do a subtraction. Okay, like this. Now if you do a subtraction, what happens? I tell you, 4x minus 2x minus 1. Okay, that means this 4 into 2x plus 1. Look at it, this 2x plus 1 is retained. Now if you do it like 4x greater than 2x plus 1, then look at it, this 2x plus 1 in the denominator is not retained. So if you can simply just you will see that this is greater than 1 and you get x greater than equal to half. Okay, so this is the solution which we get. X is greater than equal to half. So 4x, 2x plus 1. So we get this. But here if we do like this thing, we get some extra denominator over here. So let us see what we are actually getting. So this means it's a 2x minus 1 by, so I can eliminate this 4, 2x plus 1. So this is the system. Look at it. Okay. Now if this is the system, so what we can do, we can multiply with a 2x plus 1 with the numerator and the denominator. Why so? Because we have to make it sure that the full thing will be positive. So we are actually turning the denominator to be positive. So now from this, you know, we are what? We are drawing the number line. Number line is what? It's half is there, then minus half is there. From where half and minus half came? From here. Okay, so if you put a, so next line it will be what? 2x minus 1 into 2x plus 1 is positive. So you do solve the number line, put the appropriate regions. So if you put a more than this thing, say some value like 5, this is positive, this is positive. So this is taken, this is taken. So that means you get x belongs to, thus this is not taken, this is not satisfied. We put a 0 over here, the product will be minus 1. Okay, so simple, it's minus infinity to minus half. Okay, minus infinity to minus half. And now remember one thing, it cannot be equal to minus half because its denominator is there. Now here that information is also lost. Information are lost over here. So you should not do like this. Okay. So it cannot be equal to minus 1 if it is minus half. If it is minus half, then this thing will be undefined. Okay. So that means here we put, although there is greater than equal to, we put a open thing. But it can be equal to half. It's not a problem. So union with half to infinity. So this thing already you got over here, this particular, but this information is, the left hand side information which we got, that is lost. Okay, so if we put half, this is fine. It's not a problem. Okay. But if we put minus half, this becomes 0. So this will be this is the answer. So here we find a sum which we have mostly seen in the last part, solving graphically. So we get equations. Okay, all these are inequalities. So you have to draw graph. So I told you how to draw graph. So you can use the intercept form. So we try to denote this by graph. So I denoted it as 1 and this as 2, say. So you know I have discussed the intercept form. You can write like this. So if you mark this as origin, this as say 4, that means 0, 4, and this say as 0, 8, say this as 4, 0, and this as 8, 0. So I can draw these two lines taking intercept 4, 4. So I can draw this line as this. Now look at the line inequality. If you put 0, then what will happen? 0 is greater than 4. Satisfied? Not satisfied. That means it's away from the origin, the solution exists. So I put 2 arrows just to prevent it from getting untidy. The next line x by 8. So it will be something like this. Okay. Now if you put 0, then what happens? It satisfies. The equation gets satisfied. So it's towards. So that means in between these two lines. What else? X greater than 0. That means it's towards this way. That means, and y greater than 0. That means it's in the first quadrant. Okay, so that means we got this as confined, this part, kind of trapezium. Let's see the other things also. Y lesser than equal to 5. So let us draw something. So let this point be 0, 5. Okay, so this is the line which is, this is y lesser than equal to 5. So it's below, that means over here. Okay, so that means this one, below the line. Why below the line? Because anything you put below, it should be below than 5, not above. Now x lesser than equal to 5, this one. So let us assume over here a point like say 5, 0. Okay, so this point. And we draw a line. So it will be towards this. So eventually we got an area which is kind of this. So let us shade the area. So I can see that this area is bounded by how many lines? 1, 2, 3, 4, 5, 6 lines. So I'll name it A, B, C, then D, this point is E, and this point is F. So A, B, C, D, E, F is the required solution region for the given inequalities on the graph. So this will be the solution over here. Thank you.